All eyes now on the Satish Dhawan Space Center at Sriharikota. India is all set to enter the world records. In about 3 minutes from now, exactly at 9:28, we expect to hear the word liftoff. At 9:28, India will launch the PSLV, the 39th flight. Let's listen into what's happening, because this is a world record. 104 satellites will be put in space on board one single rocket. This, of course, is the XL variant, the most powerful rocket that India has and has been used earlier when the Chandrayaan was launched and also in the Mars orbiter mission. But let's listen in to the countdown clock. 1 minute from now.
प्रमोशन में कुछ ही घंटा शेष। अभियान नियंत्रण केंद्र में समय जो है वो 9:27 दिखा रहा है, माने हम केवल 50 सेकंड की दूरी पर। अभियान नियंत्रण केंद्र तथा प्रक्षेपण यंत्र में सभी विशेषज्ञ उड़ान संबंधी विभिन्न प्राचलनों का बड़ी बारीकी से सूक्ष्मता से निरीक्षण करते हुए मैं अब खामोशी ग्रहण करूंगा।
104 satellites on one rocket. The earlier record is 37 satellites by a Russian space agency in 2014. Less than 30 seconds to go. Let's listen in.
Minus 30 seconds.
Real-time programs activated.
Roger. Minus 25 seconds.
PS2 VSPPs are opened.
Minus 20 seconds. 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, plus 1, 2, 3, 4, 5, 6 of normal, 7, 8, 9, plus 10 seconds.
A perfect liftoff as usual for PSLV, and you can see in all glory PSLV negotiating the dense atmosphere, all the strap-ons firing well.
There are 4 strap-ups in this. This is India's most powerful rocket, and this is carrying 104 satellites on board. Remember, the same 4 solid propellant boosters, 4 solid propellant strap-ons were used to launch the Chandrayaan and the Mars orbiter, and it's been described as a perfect liftoff so far.
Plus 50 seconds. Plus 55 seconds.
Now all the 6 strap-ons functioning, and that atmosphere is successfully been negotiated. In about 10 seconds from now, we will see the first set of 4 ground lead strap-ons separated.
So smooth so far. Tremendous excitement at the Space Research Center. But still, fingers crossed. The ISRO chief, top officials all watching the liftoff. Fingers crossed. Now the US in the past has launched 29 satellites. ISRO's record so far has been 20 satellites, and that was in June 2015.
The remaining 2 strap-ons also are separated. Now the first stage is functioning on its own, alone, and we have steadily gaining altitude. Now the relative velocity is 2 kilometers per second, and in about 5 to 10 seconds, the first stage will complete its task, burn out and separate.
Second stage
जी हाँ, आप स्क्रीन पर पोंगिनान जी को
So
देख पा रहे
first stage successfully completed.
घोषणा करते हैं।
Now 2 of India's nano satellites weighing about 30 kgs are riding piggyback on this rocket. Nano satellites belong to international customers. Also being launched, this Cartosat 2 series, which is the primary satellite. It's similar to the 4 earlier satellites, Cartosat 2 series. They're also being launched. These satellites have a mission life of about 5 years. The 2 Indian nano satellites, INS-1A and INS-1B, developed as co-passenger satellites to accompany the bigger satellites on board the PSLV. PSLV C-37 launch has been successful, but we're still waiting to hear the final verdict from the Indian Space Research Organization.
134 किलोमीटर की ऊंचाई तक पहुंचने के बाद होता है, जो इस यान को ऊपर ले जाएगा।
The second stage is under
Second stage
operation.
performance
This
normal.
is a liquid stage built by ISRO and uses primarily unsymmetric dimethyl hydrazine as fuel. It's a very efficient stage with a specific impulse of as high as 295 seconds, and it will be burning for a total duration of 150 seconds. It will be some time before we separate this stage, and the performance till now has been perfectly normal. On your
Perfectly
screen, all the
normal
mission experts of
performance so
ISRO
far. The PSLV is
having
carrying
a
714
close watch on the
kg
launch.
main satellite for Earth
Everything
observation
as per plan.
and
And you can
103
see, or you'll be
smaller
shown
nano
shortly,
satellites
the
which will
flight
weigh, the
is
combined
following
weight
the
is
pre-flight. Now it's on the
664
screen.
kgs.
The pre-flight
The entire
positions
launch
are in red
satellite,
color, and the
the
green
satellite
color
mass is about
the instantaneous position of the vehicle. And you can see
1,378
the
kilograms,
position
and this
is
is a world
one
record
over
that
another.
India
जी हाँ,
aims
करीब
to
200
set by
किलोमीटर ऊंचाई पहुंच चुके हैं
putting
और जो परास है वो
104
370
satellites
किलोमीटर का
in
हो चुका है।
orbit.
समय
It
हम
has
250
never
सेकंड का
ever
जो
been
समय
done
व्यतीत
before
कर चुके
by
हैं, बहुत ही
any
नजदीक।
country.
जब तीसरा
Not
चरण
by
का
the
चलन
US,
शुरू होगा,
not by
तो हम
Russia.
दर्शकों की जानकारी के लिए बता दें,
37 is
4 चरणों वाली
Russia's
PSLV
record,
में
27, 29 is US
यान के
record,
दूसरे और
20
चौथे चरण में
is
तरंग करने
India's
वाला है।
past
Third
record.
stage ignited.
करीबी घोषणा कि पीएसएल जो तृतीय चरण था वो इग्नाइट हो चुका है, प्रज्वलित हो चुका है, और दूसरा चरण जो है
Third
वो
stage
सामान्य
performance
निष्पादन करते
normal.
हुए अलग। तो मैं आपको बता रहा था कि
So
दूसरे और
far,
चौथे चरण
all
में तरल
normal.
ईंधन भरा जाता है।
Stage 1
इसी दौरान
normal,
प्रथम
stage
चरण
2
के जो
normal.
RCP होते हैं उनमें भी ईंधन के रूप में MMH
The
मोनोमिथाइल
liftoff
हाइड्रोजन
was
और
described
ऑक्सीकारक के रूप
as
में
perfect.
नाइट्रोजन के ऑक्साइड मिश्रण अर्थात MOM3 भरा जाता है।
India is
समय
on its way to
करीब
becoming the
करीब
first country
5
to
मिनट
launch
का समय
104
बीत चुका
satellites
है।
on a
तृतीय
single
चरण
rocket.
अपने निष्पादन को
The Russian Space
समर्पित
Agency
करते
holds a
हुए
record with
लगातार
37
गंतव्य
satellites.
तक
The
आगे
Russian
बढ़ता
Space Agency had done that in
आप अपनी स्क्रीन पर देख पा रहे हैं।
2014.
एक
And in
तरफ range और
2017,
altitude,
India is aspiring
परास और ऊंचाई की
to
तुलना,
successfully
अनुमानित
launch
वक्त जो है, उसी को follow करता हुआ
104
अवलोकित पथ।
satellites.
और दूसरी तरफ आप दाएं तरफ देख पा रहे हैं ग्राउंड ट्रेस, माने किस तरह से श्रीहरिकोटा से आगे बढ़ता हुआ जो लॉन्जिट्यूड है उस तरफ बढ़ता हुआ
Third stage
हमारा
performance
यान।
normal.
How you are seeing this information is now, I'll tell you next. We use a network of ground stations for tracking telemetry and telecommand activities related to this mission. The health and trajectory parameters of PSLV C-37 is available to these ground stations via the antenna mounted on the rocket along with the required subsystems. This information is sent to Sriharikota
6
ground
minutes.
station in real time, and we shall be showing you this information, or rather we are showing you this information on the real-time display screens. The entire ascent mission of C-34 till orbit is tracked by ground stations at Sriharikota, Thiruvananthapuram and Mauritius. Cartosat 2, INSAT 1A, INSAT 1B, sorry, INS-1A, INS-1B, and a few nanosatellites
Third
separation will
stage
be visible
action
from
completed,
Mauritius.
vehicle in
However, the
posting
most of the nanosatellite separations will occur after we have the Mauritius ground station loses the vehicle, that is the vehicle is out of the sight from Mauritius ground station, and hence we will be recording the separation data on board, and when around 500 seconds later Troll ground station in Antarctica will acquire the vehicle, then all the things will be again shown to you. So we will confirm to you the separations of 72
Plus 7
of the
minutes.
101 nanos in during this period, and again last 20 separations will
Coasting
be
normal.
visible from Troll, which will be shown to you in real time.
जी हाँ, कोस्टिंग बहुत छोटी, जैसे रेंज ऑपरेशन डायरेक्टर पुंगनान जी बता रहे थे। तृतीय चरण प्रमुचन के 264 सेकंड के बाद है, ये यूं कहें कि दूसरे चरण के पृथक्करण से
Looking at all
1.2
space
सेकंड के पश्चात
researchers,
तीसरा चरण प्रज्वलित
scientists,
हो गया, तो जो
others who are there
227.6
watching
सेकंड का
developments
ज्वलन यान को
very,
देकर
very closely, keeping a
यान को
keen
एक
eye
अभीष्ट
on
ऊंचाई दे देता
developments.
है।
And
अब हम बहुत ही
Professor
करीब
Amitabh
तृतीय
Ghosh
चरण
now
के,
joins us on the broadcast,
प्रज्वलन के बंद
one of the
होने
leading
पर,
voices
बंद होने
on
की प्रतीक्षा में,
space.
और चतुर्थ
Sir,
चरण के,
your comments on what India is witnessing, history being made with 104 satellites being launched on PSLV C-37, sir.
So I think it's a very big achievement. I think it really proves that India is out to achieve in the space sciences. If you recall that, you know, this is not a trivial achievement.
Okay.
And if you, just like Mangalyaan, you know, it put India on the kind of roadmap, and people in the space business were suddenly aware of India's capabilities. So this also goes a long way. And if you notice that the payload is completely international.
Yes.
So that means that in the international launch market, there has been sort of a proof that India is absolutely going very competitive here.
So Planet has its nano satellites on board, 104 in all. India has, you know, her satellites on board. How complicated is this, with the fact that 104 satellites are being put, you know, in space simultaneously? The previous record was 37 in 2014 by Russia, sir.
So yes, this is of course a fairly complicated maneuver. It's a fairly complicated maneuver, but at the same time, you know, there are many. The space is really a frontier. You can think of many more complicated things as well. But to begin with, this is a very complicated maneuver and shows India's technological dexterity. So yes, it is very complicated, I would say. But of course, you should also remember that space is a frontier which is very difficult, and there are many equally complicated and even more complicated technological exercises.
So, for the benefit of, you know, Indians who are watching this, what does this achievement mean for Indian space research, sir? The fact that, you know, India takes a lead in putting 104 satellites into space together, simultaneously.
So, I wouldn't say that a single event is as definitive as the entire trajectory. So, if you notice that India is in a very solid trajectory in the space sciences, there are talks of another mission to Mars with a rover. Then there's talk of Chandrayaan-2. There's talk of a Venus mission. So I would say the whole scale, and then there's talk that the GSLV is supposed to be tested sometime this year. It will become operational. So I wouldn't really focus too much on this event as the whole trajectory, which is very positive. So multiple things are very positive for the Indian Space Research Organization. One is the technological capability and this ambition. Two is there is absolute support from bipartisan support from political parties. For whichever government there is, they're very supportive of ISRO, and I think this time ISRO got a 23% budget increase. So on the whole, I would say it's very. The next 10 years is going to be very exciting for ISRO, what it will do for India.
And especially, you know, as you were very rightly pointing out, that the next focus, Mangalyaan-2, another mission to Mars or the Venus mission. But what are we hoping to achieve with this, sir?
What are we hoping to achieve? See, I think the cost, there are multiple advantages. The biggest advantage is, I would say, the branding perspective. This clearly tells the world that India is a very superior technological player. So it is not just a place where you have we are at very high level. We can execute very high level engineering tasks.
Right.
Okay. The other are largely intangible, like this. The space program helps mobilize your scientific talent. This is the reason people come to the sciences. There's capability in STEM education. This can be a stepping stone to bring youngsters on board interested in space research. This can be a platform for space research. And one of the very big things that we underestimate is a lot of developments in technology happen because of as offshoots of space research. For example, you know, there are many NASA technologies which were developed for the moon mission, and then they later came on board in commercial applications in the health sector, in various industries. So it's a, see, I think space technology, see, when John F. Kennedy mobilized the United States to go to the moon,
Yes.
he just did not go to the moon. He also created a technology capability which is which really helped the U.S. Compete industrially as well as economically. So it's a very, I think it's a very wide set of advantages.
And through this, I mean, we're also aspiring to put a man on moon or a woman on moon. You know, that also will show where we've reached as far as technology is concerned, sir.
So, okay, so you're talking about ISRO's plans to put a human on the moon.
Yes, sir.
Right. So I think, so we are quite away from that point. It is because, see, we probably, if you see you need a very large launch vehicle to go to the moon, to transport humans as well as the infrastructure required for humans to the moon. So, so to really materialize that, you need a launch vehicle which has probably 10 to 40 times the capacity of this PSLV. So I think we are still a distance from that. So first is GSLV has to come on board, and then maybe ISRO will concentrate on developing a launch vehicle which is even bigger than the GSLV.
Right.
So I think you know this. So and then ISRO's plans for the reusable launch vehicle, that is kind of just starting out. So I think in that scheme of things, landing on the moon is still far away. And also you have to remember that, you know, you have to get the blessings of the public and the government. For the moon mission, it's much more expensive. Like the humans on the moon
Yes.
endeavor, it's going to be much more expensive. So you need a broad buy-in from the government and the public to do this.
And
So-
what about the West? You know, would India be seen as a challenger, or you know, the fact that we can launch satellites for other countries and perhaps cheaper than Europe or America? Will they respect this? Will they challenge this? Will they run us down?
No, I think quite the opposite, you know. So, so right now, changes in launch vehicle technology are such, if you're following Elon Musk's SpaceX and Jeff Bezos' Blue Origins, what they are trying to do is they are trying to cut the launch cost by as much as 90% by reusing the launch vehicles.
Right.
So you have to understand that India has to play catch up. I mean, whatever cost advantage is there will vaporize once these new technologies become possible. So you have to understand that there is going to be competition. The future by any means is not going to be easy. Just as in any technology field, you have to constantly be up to date on recent developments to be on top. So here ISRO has to be on top of recent developments in launch technology, which will drastically reduce cost of launch to stay competitive.
Okay, but currently, in the current scenario, if a country and if a company has to launch its satellites, would they prefer India? Are we currently cheaper than options in the West?
See, I think it depends. It is certainly cost competitive, but it certainly depends. So there are many variables here. So what is the satellite, you know, carrying? So that's one thing. There's certain say there is a military satellite of a certain country, and
Yes.
they may not be willing to launch it in another country. So they might want to launch it in an indigenous vehicle. So there are there are a lot of metrics here, but having said that, ISRO is certainly one of the possible solutions.
Okay, and currently, you're looking at this satellite, the rocket launch, the separation. At what stage will we say it's perfect? The liftoff was described as normal. The stages have been described as normal. At what stage can we say, India's done it?
See, I think it's up to ISRO to make that assessment. I think so far the launch has gone picture perfect, I think. But, this is perhaps, it's a better question to ask ISRO managers than to ask me.
Okay, yeah, because so far we've been told that it's a perfect liftoff, it's picture perfect at this stage, it's being monitored at Mauritius, it's been described as perfect at that level, and I think at one stage, Antarctica, the station there has to give the all clear. Is there a time frame for all of this to happen?
So, I mean, see, the health of all this, all the payloads, so there has to be a lot of checks here. So there's no fixed time frame. It's just that you have to make sure that everything that was launched is fine and in the right trajectories. So that depends on, how quickly ISRO gets the information and how quickly ISRO updates the public, I guess.
What could have gone wrong in this? Because satellite launches are quite a technical task, as you were pointing out, and at every stage, from the liftoff stage itself, lots could have gone wrong, sir.
See, there are many things that can go wrong, There are many things that can go wrong. A slight difference in orientation, something wrong with the launch vehicle. See, historically, many, accidents have happened. And that is just normal. And so, so the fact that ISRO has near perfected the PSLV is, I think, it says, it speaks volumes for its capability.
Okay, sir, we're looking at these images for a moment. We're just dipping into the audio that's coming from the Sriharikota station at the center, Satish Dhawan Space Center. Let's quickly listen into what's happening on ground.
Ending the ejection of all 101 nanosatellites from our esteemed customers.
जी हाँ, जैसा कि रेंज ऑपरेशन डायरेक्टर ने और बाद में हमारे साथी कमेंटेटर ने बताया आपको कि जो 101 उपग्रह हैं उसमें से कुछ उपग्रहों को 4 पेयर जो थे उनकी नैनो उपग्रहों को उसको हमने प्रक्षेपित कर दिया है और वो दिखा रहा है और बाकी उपग्रह भी यान से लगातार प्रक्षेपित होते जा रहे हैं, लेकिन यान से मिलने वाला संकेत हमारे किसी भी भूकेंद्र से रिसीव नहीं हो रहा है, प्राप्त नहीं हो रहा है. इसे हम लॉस ऑफ सिग्नल कहते हैं. लेकिन यान सामान्य रूप से आगे बढ़ रहा है और इन सारी गतिविधियों को हम यान में ही लगे हुए रिकॉर्डर द्वारा प्राप्त कर रहे हैं. जैसे ही हमारा यान ट्रॉल भूकेंद्र की सीमा में आएगा, वो सारा डाउनलोड किया हुआ डेटा हम आप तक तुरंत पहुंचाने की कोशिश करेंगे. इस समय हम आपको कुछ घटनाओं के बारे में बताना चाहेंगे. ये जो आप